All right, video number 2. So now that we've graphed exponential functions and explored their base features, what we're going to do is graph transformations. And we're going to use y equals 2 to the x as our base graph. Now we've actually already graphed one transformation. It's the reflection of the x values over the y-axis. And I want you to just think about what changed. Nothing, right? The asymptote, the intercept, the domain, and the range stayed the same. So what about 3 more transformations? The next transformation we're going to look at is a transformation up here in the exponent. What is this a transformation on? It's up in the exponent with the x. Think of this as in a bracket with the x. So what is this going to do? Well, it's going to shift the graph to the right by 2. Just like all the transformations on XR, it's always opposite. So then let's think about what that graph would look like. Now we can go through and actually fill all this out before we even do it, but let's just graph it and then we'll pull out that information and look to see what changed. When you're graphing y equals 2 to the x, okay, you have the graph of the base graph on your formula sheet. And it has nice points laid out. So you'll see here it goes through 0, 1, then we've got a point at 1, 2, 2, 4, 3, 8, and on the other way you're going a half, a quarter, an eighth. Okay, so if you wanted to label those points, you could, but really you should be able to figure them out anyway. But we're thinking about that base graph being y equals 2 to the x, so you could even kind of draw yourself like a little sketch in here if you wanted to. So it's going through 0, 1, 1, 2, 2, 4, 3, 8, and we can just kind of do this like dotted graph. And what we're going to do is we're going to take all these points and we're going to move them to the right too. Now you could write down what the points are and then say to the x value I'm going to add 2, or we can just simply take that graph we just drew and move it to the right too. So I'm going to take this y-intercept and I'm going to move it to the right 2. And then I can even just do the shape from here. I know from the asymptote you go over 1 and up 2. From the asymptote you go over 2 and up 4, right? Which is moving that point to the right 2. I could take this point, I could move it to the right 2, right? However you want to do it. And in fact, this one isn't like a true, you have to do it via transformations thing, because we also could have just used a table of values, right? Because they're always going to give us the equation. So if I think about if I wanted to graph this, so again, you can think of your base graph and how it's transformed, or you could simply plug in values for x and solve for y. Now we know that it's moving to the right 2. So instead of having that point at 0, 1, we know it's going to be at 2, 1. So maybe I put an x value of 2 in the middle, because then when I plug in x is 2, I get 2 to the 2 minus 2, which is 2 to the 0, which is 1. So then I would pick 2 values maybe down from there. I'd pick 2 values maybe up from there to give me the shape. If I plug in x is 3, I get 2 to the 3 minus 1, which is 2 to the 1, which is 2. When I plug in 4, I've got 2 to the 4 minus 2, which is 2 squared, which is 4. And then the other way, 2 to the 1 minus 2 is 2 to the negative 1, which would be a half, and then I would have a quarter. So up to you how you want to graph this. You can transform points, you can transform the picture of the base graph, you could do a table of values, whatever works for you. But what I'm looking for is, did the asymptote change? Well, moving it to the left and to the right, all that's going to do is take that graph and kind of move it along the x-axis, but it's not moving the location of the asymptote. So the asymptote is still y equals 0. What about the domain? Is the domain still negative infinity to infinity? Sure is. Did the range change? No. I mean, if you can't change the asymptote, you're not going to change the range. So it's still y is greater than 0 in set notation. I can't stop myself. Or 0 to infinity in interval notation. Did the y-intercept change? Yeah, for sure. It's like this point now. To find the y-intercept, the easiest thing is to always let x equal to 0 in the equation. So if we plug in x is 0, we get y equals 2 to the negative 2, which is a quarter. So my y-intercept is at 0 and a quarter. Awesome. So what changed by moving my graph right to? Just the y-intercept. All right, let's move on to the next graph. So what transformation is this going to be? Is it in the bracket with the x? Nope. It is out here. So it's going to be a transformation on y. Y is as it should be. So where's this going to go? Hopefully you're all saying down. So this is a graph of y equals 2 to the x moved down 2. Now, what is that going to change? Well, again, you've got that base graph of y equals 2 to the x, which is going to look something like this. 1, 2, 2, 4, 3, 8. Right, there's my base graph. And what's going to happen? Well, we're going to take every single point and we're going to move it down 2. Or, don't forget, you're also allowed to do a table of values. So this is y, x, and y equals 2 to the x minus 2. Now we know that this is a transformation on y and not x, so my x values will stay the same. So I could pick -2, -1, 0, 1, 2. I've stopped picking the 3's. You kind of will know where they go. So when I pick in a point like 0, 2 to the 0 is 1. 1 minus 2 is -1. So this point here is moved down 2 to -1. Now, if you know the shape of it, again, you could kind of draw in that imaginary asymptote line and just say to the left, I'm going to approach it. And then to the right, I'm going to grow. So if I want to do exact points, I'm going to go up, over 1, up 2, over 2, up 1, 2, 3, 4. Or I could take each point and move it down 2. There we go. So many options. And really, you're not going to be asked to replicate a ton of the graphs, like on a test situation or whatever. What I'm looking for is, can you tell the features? And then what would the features be if you did this transformation? So this is my graph of the graph moved down to. If I want to complete the table of values, right, this is 2 to the -1, which is a half. A half minus 2 is -1.5. 2 to the -2 would be -1/4. So this would be oh, sorry, I wrote -1.5. You know what I meant here. Yes, that is -1/2, isn't it? Let's actually do it. So 2 to the -1 is 0.5. 0.5 minus 2 is -1.5, yeah. And then 2 to the -2 would be -1/4. Not -1/4, that's where I was messing up in my head. 2 to the -2 is +1/4. Right? 2 to the -2 is 1 over 2 to the 2, which is 1/4. So we've got 0.25, integers, minus 2, which is going to give me -1.75. I don't know if that's going to show up on my key. Let's just put what we want it to be there. So we're going to say -1.75, right? So you could picture it over here. We've got that 0, -1. We've got -1, -1.5, -2, -1.75, or you can kind of think about it from the x-axis. Over 1, up a half, over 2, up a quarter, over 3, up an eighth, and so on. And then on the other side, when we put in 1, we've got 2 to the 1 is 2, 2 minus 2 is 0. 2 to the 2 is 4. 4 minus 2 is 2. So we could check that we have that 0.22. Okay, so that's the table of values. But really what I want to look at is, what did that affect? Did it affect the asymptote? Yeah. The asymptote is a horizontal line with an equation y equals. Since it was y equals 0, it's moved down 2 to y equals -2. Did the domain change? Nope. Did the range change? Oh yeah, because my asymptote moved down 2, all of a sudden my range is out -2 to infinity. So far my asymptote has changed and my range has changed. Would my y-intercept change? Well, I don't know, let's test it. Y equals 2 to the 0. Remember, if you're ever asked for y-intercept, just plug in an x value of 0. We get 1 minus 2, -1. So we get a y-intercept at 0, -1, definitely changed. So notice how up here, the only thing that changed was the y-intercept when we did a right to. But here, when we did a down to, lots of things changed. In fact, the only thing that didn't change was my domain. All right, we have one more transformation, and then we're going to put all this in a summary. And this is a negative out front. So again, is it in the bracket with x? No. So it's a transformation on y. It is a reflection of the y values over the x-axis. Now, could you, before you even graph it, could you determine asymptote, domain, range, and y-intercept? Well, if you think about the asymptote, just by taking the graph and flipping it upside down, that's not going to change the asymptote. By flipping it upside down, is that going to change the domain? Nope. In fact, nothing changes the domain of a exponential function. Will it change the range? Well, yeah, it's going to be opening down. So instead of 0 to infinity, it's going to be negative infinity to 0. And is it going to change my y-intercept? Yeah, everything changes my y-intercept. So let's plug in x is 0. We've got negative 2 to the 0. Now, this is not bracket negative 2 to the 0. This is negative 2 to the 0. So it's going to be a y-intercept of negative 1. So yeah, definitely had a change in my y-intercept. So my asymptote didn't change, but my range changed and my y-intercept changed. Okay, let's sketch it. So for me to sketch this one, I've got that y-intercept of 0, negative 1. Then I can think of all the points reflecting over the y-axis, or I could do a table of values. Y is equal to negative 2 to the x. Really what's going to happen is we're going to pick those same x values, and my y values are going to be reflected. So instead of a quarter, I'm going to get negative a quarter. Instead of a half, I'm going to get negative a half. Instead of 1, I'm going to get negative 1. Instead of 2, I'm going to get negative 2. Instead of 4, I'm going to get negative 4. So I'm going to take this graph and I'm just going to flip it upside down. So I'm going to approach negative infinity over here, and then I'm going to approach that asymptote of y equals 0 up here. All right, so now what I want to do is just do a little summary table, and then we're going to do one more graph, and then we're done. So we're going to do one where there's a couple of transformations in there. Okay, so let's start off by just putting asymptote, domain, range, and y-intercept of my base graph. So my base exponential graph, y equals 2 to the x, has an asymptote at y equals 0. I don't know why I've gone to green. The green doesn't show up the best. I'm just going to switch back to blue. Okay, so the asymptote is y equals 0. The domain, negative infinity to infinity. The range is 0 to infinity. And the y-intercept is at 0, 1. So those are my base features of an exponential function. What we're going to look at is what transformations can change the value of the asymptote, domain, range, and y-intercept, and what it would look like for the transform graph. So for example, with the asymptote, the only thing that changed the asymptote was moving the graph up and down. So if you had y equals 2 to the x plus d, so it's this up down transformation that will change where your asymptote is. On your transform graph, whatever the d value is, that's going to be the value of your asymptote. What about the domain? Well, nothing. So the domain of your transform graph will always be negative infinity to infinity. Now, what about range? Is range affected by a horizontal transformation, so transformation on x? No, because range is a y value. So there's two things that can affect my y value. There's that up and down transformation, so y equals 2x, 2 to the x plus d, so that up, down. And that's going to affect where your domain is. So for example, if you move it up 2, then it's going to go 2 to infinity. If you move it down 2, it's going to be negative 2 to infinity. But no matter what, it's going to be whatever that d value is, so wherever that asymptote moved to infinity, unless you also reflect it. So let's say we had a negative 2x plus d. So let's say we went and had a reflection, reflect in x-axis, and an up-down. That would mean that instead of having d to infinity, the graph is opening down, and so it would be negative infinity to d. And then lastly, what about your y-intercept? Well, my answer to what affects your y-intercept is everything. So my answer to how to find the y-intercept is always let x equal to 0 and solve for y. All right, so knowing all of that information, we are just going to do one more graph. And I choose this graph because the textbook does it a little funny. So we're going to look at this and we're going to decide what the transformations are, what the asymptote, domain, range, and y-intercept are, and then we're going to graph it as well. All right, I just went and did a little Desmos preparing just so you didn't have to watch me type. This is a little bit of a pet peeve I have with our textbook. If I was going to graph this, we never look at transformations in this way. If you think about y is equal to f or a f of b x minus c all plus d, this is the normal way to do a transformations question. You always have what's in with the x written first, and then there's this factored form. So if I was to do that with this equation, I would do this as 2 to the negative x plus 2. And then to make it into this factored form, I would factor out the negative 1 to be left with x minus 2. And this is how I would determine my transformations, because this is the way we always do transformations. It's the way that we're going to do it again in chapter 6. So I don't know why they decide to break tradition in chapter 5, but they do. So when you look at the back of the book, transformations in words might be a little bit different than what I say. So when I look at a graph like this, I'm going to move from left to right. So this is a reflection of which values? Well, it's in the bracket with the x, so it's going to be a reflection of, I wonder if I could just type this instead of, and my printing is so horrendous. So it's a reflection of the x values over the y-axis. And then if you think about that next part of it, right, look at this bracket. So this is a reflection because it's a negative with the x. It's a reflection of the x values over the y-axis. And then what would this make it do? Well, it would make it go right too. So that's number 1. And then I'd say right 2. And this is the way that I like to graph these. It makes it consistent between every chapter and everything is as it should be. So if I went to go and sketch this now, I have 2 choices. I can think of my y equals 2 to the x graphed. I can reflect it in the x values over the y-axis. Boom. So all of a sudden it's like that y equals 1/2 to the x graph. And then I can move it to the right too. So I know, can you kind of picture that reflection, right? And then we're going to move it right too. So it's going to have this 0, 1 is going to be over here. And then the graph is going to approach that asymptote. And then to the left, I'm going to go over 1 up 2, over 2 up 4, over 3 up 8. Now, if that was too much for you, you don't understand what I did in transformations there, remember you have 2 other options. You can take the points. Take each point. So if I had a point like 0, 1, this is going to multiply the x value by -1, and then it's going to add 2. So that's going to give me a point at 2, 1. Oh, there it is there. And you can do that for every single point on the base graph, or you could draw a table of values, right? We've got x, we've got y equals, and you can put it into this equation because it's a little bit simpler, right? And you could just pick values for x. Now I know this has been moved right too. So instead of picking x is 0, I'm going to put x is 2, and then I'm going to go 1, 0, 3, 4. If I plug in x is 2, y equals 2 to the 2 minus 2 is y equals 2 to the 0, which is 1. Then if I put in 1, I get y equals 2 to the 2 minus 1, which is y equals 2 to the 1. So when x is 1, y is 2. When I put in 0, I've got y equals 2 to the 2 minus 0, so y equals 2 to the 2, which is 4. And then the other way, it's going to go 1/2 and 1/4, right? So whatever kind of works for you, but this is going to be the picture. And again, you're not always going to be asked for the picture. Sometimes you might just be asked for asymptote, domain, range, and y-intercept. When you think about this graph, all the transformations were with x. So did my asymptote change? No. Did my range change? No. Does my domain ever change? No. Does my y-intercept always change? Yes. So my y-intercept you can find again by plugging in x is 0, even though we've already done it, right? Let's just show that work. And we get a y-intercept at 0, 4. So this is how I like to do it. And what I'm going to prove to you here, just on Desmos for a second, is that this is y equals 2 to the 2 minus x. This is me rewriting it as y equals negative x minus 2. Okay, same graph. Then I want to show you what the textbook does. Okay, now the textbook is a little bit of a funny duck. So instead of saying that it's a reflection and then it's been moved to the right, they move it to the left and then reflect. What? So what they do is they actually do this in the order that it appears. So they take this 2 and they're like, okay, everything with x is opposite up here, so this is going to make me go left. So if you think about a left transformation, that's going to look like this. And then they reflect it. So when they reflect it, they are reflecting y equals 2 to the x. Let me just put this in here. So this is y equals 2 to the x, right? So they took this y equals 2 to the x, they moved it to the left 2, and then they reflect it in the x values over the y-axis, which is going to give it that same shape. Now, the only way I can show that is by plugging it in as we look at the transformations, which is why I find this so funny. So it's negative bracket x plus 2. Oh, sorry, minus 2. Oops, minus. So we know that that's the final shape, but they just do this really weird thing where they graph it kind of bizarrely. But just know that we can do these things as we have always been doing it. So for me, I like to think of this as a reflection of the x values over the y-axis, and then I like to move it right 2. But you could say that it went left 2 and then reflected. It goes against every grain in my body, everything I've ever been taught about transformations, but it does work. If you think about it, if you reflect it and move right, it's the same as moving it to the left first and then reflecting it that same amount over the y-axis. So you do you. When you're saying looking at the back of the book, just be aware the transformations may be written differently, but you'll notice that instead of reflect and then right, they'll go left and then reflect. And that's fine. It's totally fine. But if I can get you to do this, it's better for you going forwards. Awesome. Go practice your transformations.